Yeah.
Okay, so thank you for attending. Now I wanted to ask one last question. I wanted for you if you could give us a demonstration of your participation in the project.
Okay, of course. Let me give you a bit of the overview. As I said, our pilot is regarding smart, energy efficient, health safe buildings. We started with a basic IoT system which was monolithic, and we had to transform it to the aerOS ecosystem, like adapting to the domains that we have to implement. Apart from the transformation of the IoT system to be an aerOS service, we also worked in delivering AI components, both regarding the health forecast by measuring and utilizing the sensor data coming from various sensors that are deployed in the rooms, but also on an energy efficiency calculation AI model, which is give us the idea of how the buildings are behaving regarding the energy consumption. So we are starting with the components of the IoT basic transformed application that was delivered by IoT, two AI systems that have been delivered with NCSRT and UPV support, and the other two partners of the project, Focus and Infosys, have developed the components that interact with the users, so that to provide smart recommendations to the employees approaching in the building, where to sit, so that to make better use of the health and energy targets that are set by the building facilitator. So these components are the recommender developed by Focus, and the web GUI that is actually developed by Infosys. Here we have the GUI supposed to run in the mobile phones of each employee approaching, and it's a way to interact with the system. This is the GUI of the web GUI logs that are actually showing the interaction with the user. This is the health forecasting module that is actually calculating continuously the health index of each room. Each room gets a score from 0 to 100. 100 means that it's the most health safe environment, and based on this health index, the recommended, also considering the results of the energy, let's say, forecasting AI component, as well as some other heuristics coming from the user preferences, is actually doing the final assignment of a seat to an employee approaching. So here you see how this is continuously recalculated. So let's assume that I am approaching to the building. First of all, one of the heuristics that a user can actually influence is to say that, in the past I have been, I prefer to sit in this desk, so in case these are health safe options, I would prefer to be assigned to this special seat. So while approaching, we simply get a recommendation from the system that you see here, asking for recommendation, which is actually coming to the recommender that uses the data from the forecasting engine to actually propose to the user the appropriate room to actually sit. What is important to say here is that this forecasting engine not only is actually calculating the health index, but also when a room is actually found to be very unhealthy, it invokes the actuator component that is actually is in charge of making smart decisions on opening, for example, the air conditioning, or closing or opening the air purifier, depending on which of the sensor data need to be adapted so that to recover the health of the system. So these all components are actually communicating by the data fabric of the aerOS system, using the semantic interoperability capabilities that we see with the Orion LD context broker. So, okay, here we have finally the final recommendation. As you see, the desk that the user preferred to is available, so he can book it. And automatically then the occupancy of the room changes, that reinforces the calculation of the health index in the room and so forth. So this is a bit of the demonstration of the end result, and we believe that we have very successfully used the aerOS services in order to provide this kind of installation to many buildings very easily and very adaptable regarding the deployment. Yes. Okay. You can